We've got 24 seconds, and like I said, you should not just be started, you should be almost done, because this problem does not take long. I've already got a lot of people that are done and just waiting. Okay, we're going to go ahead and get started. Let me do a quick people's shoulder, make sure people are good to go. Let me see what you got. Perfect. So you can do this with everything. Because then you need to sign his Okay, I think we're good. I think everyone's done. Wonderful.
Are you serious?
I'm serious. That's a good high five too.
Yeah.
Solid. How was your presentation? Oh yeah, you said someone said you were going to work at it. I forgot we were talking about.
Chile was nice.
All right, here we go. We're not going to take much time to talk about this one, but this is kind of like to summarize a week of Unit 4, what I would consider more of a like level 1, just starting off problem with this. So if this is challenging for you, let's make sure we get this down, because now we're just like building and kind of getting more complicated with this. Okay, but we label our triangle. We had to find the other side, so raise your hand if you can tell me what the other side of the triangle was. I'm not going to draw it this time. Come on. 4. You could have even used Pythagorean theorem, or some people actually know that one. It's a Pythagorean triple, the 3, 4, 5 triangle. I know some people might have that memorized. And then opposite over hypotenuse, no, sorry, adjacent over hypotenuse should have given you 4 over 5. Okay?
Yes.
So if you're not sure about that one, let's talk, but I'm going to keep moving for the sake of today. So, problem set 1. All week we've kind of been seeing if we're going to have that for Thanksgiving, and y'all have been doing a really good job of coming in and getting started on your youth first. So we are going to leave problem set 1 as a optional practice for over Thanksgiving, but I want you to enjoy your break, and so we get kind of a freebie on this one. So I'm going to put a 10 in the grade book, but if you at any point, like later on in the unit, decide to go back and use that as like review or practice, and you want me to ever check it over, you can turn it into me and I can also check it if anyone works on that, okay? Other than that, today we have the last Unit 4 lesson before the break, which we're going to cover negative and coterminal angles, and then we'll pick up when we get back, because tomorrow you'll be doing another SAT prep day and just practicing some problems with that. And I'm going to be with the seniors on their service/natural science trip. Yep. The first, if you look at the calendar, I believe it's the Friday of the week we get back. Like we'll have some more lessons Monday, Tuesday, Thursday, because Wednesday's another SAT prep day, and then a quiz on Friday over like all this beginning stuff. Okay? Good question. Okay, so let's figure out what a coterminal angle is. I'm going to kind of like push us forward ahead, hopefully a little quicker, because I want, instead of doing just normal practice today, I've designed a little game for us to try out that we did in most of my first classes today. We had time to get to, and they seemed to like it. So we're going to try to get there. So let's talk about what a coterminal angle is. Follow with me right below the do first where it says explain. It says by defining angles in terms of their rotation about a vertex. Two angles can have the same initial and terminal side. Remember we said we start with the initial, the terminal is the one as our angle like opens up. This is our terminal side, initial, terminal. We can have the same initial and terminal side, but have different measures. So for example, this is roughly, I don't know, like 45 degrees, if this is 90, straight up and down. Y'all see what I'm doing? I can't tell from where you are, but roughly like 45 degrees, okay? I could express this initial and this terminal side as 45 degrees, but actually I could also express it some different ways. For example, instead of going up 45 degrees, I could go negative down and around and get to the same spot. And I could say how many degrees backwards to get to that same position. So that is what we call a coterminal angle. If it gets us to the same terminal side but has a different measure, such angles are called coterminal angles. So that's a vocab word that we need to keep in our head when they ask, is it a coterminal angle? You're thinking, is it in the same position but just a different measure? It's kind of like a 1/2 is equal to 3/6, right? Like they are equivalent, they are the same, but they look different, right? So they're going to look like different measures, but they have the same sides. So in the figure below, angles alpha and beta are coterminal. So these are two more symbols, kind of like theta. We've seen a lot. You could also refer this one we call alpha, and this one that looks kind of like a V we call beta. Okay? So they're just using that to represent two angles in this picture. Okay, if we have our initial side here, it's always going to start our initial side here. And if you look at this picture, the terminal side is down here. One way I could get there is by starting at my initial side and opening it up this way like that, right? However many degrees that is. From what we talked about on Monday and Tuesday, is that a positive or a negative angle if I open this direction?
Negative.
Positive.
Yeah.
I got this.
Positive. Because remember we said it's kind of weird, counterclockwise is actually positive. Okay? And then if I go instead from my initial side and I go to my terminal side, instead of going up I go down and around, it would be negative to go that way. So those are two different, notice this, the like space of that angle, like my red arc and the pink one are different, right? And so it's not just like negative 100 and positive 100, like they are different positive and negative numbers to get to the same location, right? Okay, so what do you notice in general about alpha and beta together? Raise your hand if you can make an observation about alpha and beta together. Brenda?
They both add up to 360.
Like I can use that together, they add up to 360. So to find one, we can kind of subtract from 360 if we have the other. Okay, interesting. So this is a positive and a negative coterminal angle. Now a coterminal angle could also be a positive with another positive. So let's talk about how that would be possible. So if you take a look at this second picture, watch with me really quickly. Our first angle, alpha, notice I went in the positive direction to the terminal side. I'll make those a little more clear. Initial, terminal, right? Okay, if I still go in the positive direction, but I pass it up and I go all the way around my circle and then back through, notice I ended up at the same spot and I traveled in the positive direction, but I just traveled over 360 degrees, right? I traveled 360 plus the extra and I ended up there. So I can subtract from 360, but I can also add 360 to get a coterminal angle. I could go a whole nother circle and get to the same spot, right? If you're in a location and you go in a perfect circle around, we end up in the same spot, right? And we're talking about coterminal means we end up in the same spot, the same terminal side. And so we can add 360 as many times as we want, or we could subtract 360 as many times as we want, and we will end up with coterminal angles, okay? All All right, so let's look at an example with a number. Y'all have a blank space right there, right? Okay, so it says example. Let's use not 45 like I did with my arms. Let's use like 60 degrees as an example. So draw your little coordinate grid for me. Roughly, who can describe to me, if this is my initial side, where should I put my terminal side for 60 degrees? Y'all should have a sense of where 60 degrees is. Joanna? Right there. Bigger or smaller than 90? It's a little smaller than 90, not quite to 90, a little closer to 90 straight up than 0, but something around there is like 60 degrees, right? Okay, so that's one way to represent that initial and terminal side. However, let's think about if we can come up with a negative angle that would get us to the same spot. If I want to get to right here, I could go down and around to there, so I could go from here and around. Chime, do you know how many degrees that is? A little louder, you got it? Negative 300 degrees, because think, the total circle is 360, and this piece is 60. So one way to think about it is saying 60 degrees minus a full circle, 360 degrees, would get us to negative 330 degrees. Or you can think about it as what piece is left.
Wait a minute.
Oh, thank you. Everyone was like, you're wrong. Literally, I looked out the crowd and people looked like disgusted. Like, terrible. Okay, sorry. Negative 300, am I better? Okay, we're good? Okay, so we go around, but not a full circle. Good? Okay, next up. Alright. Let's do the same angle. 60 degrees. Except let's find, so this is a negative coterminal angle. It is a different measure, but it ends up in the same location. Let's talk about a positive angle. We could do that by, we still have to go forwards in the positive direction, but I have to go then past it, do a full circle, and then back to 60. I'm always starting at my initial side. I'm starting at like basically 0 degrees counting on my protractor, and I'm counting a full 360 and then 60 extra. And so what I'm basically doing here is 60 plus an extra 360. I can add a circle, and I would be a total of, let's see if I can do this one. Keep them for school.
Did you pull 405? Times 420.
I'm sure.
She said 405.
Okay, we're good? Yo, I'm just gum based of the attic. I don't know, okay. Like hot, no, okay, here we go. Got it? Negative and positive. Happy? So key idea is I'm gonna kind of say like add full circles, or I could subtract full circles and I'll end up in the same spot. So I'm like adding 360 or subtracting, or we're gonna talk what that means with radians. And again, we just added one 360 or took away one 360, but I could technically add any multiple of 360. I could go around multiple times. So right here where it says degrees and radians, let's write down our overall rule. And we talked about degrees, but let's translate that as well to radians. So for degrees, if I give you an angle theta, the one we had was 60 degrees, but let's just call it any general angle theta. If I add 360 degrees, I'll end up at a coterminal angle, but technically I could add any multiple of 360, so I'm going to write that as 360 times n, where n is any integer, and I'll write that because some people have been like, what's that? N right? Because if I chose n to be like 3, that just means I'm adding 3 circles. I should end up in the same spot. If n is -1, that just means I'm taking away a circle or taking away 360. Okay? So for an example, if I ask you to write for me all angles that are coterminal with 60, y'all with me? This is just 2 angles that are coterminal with 60, right? If I ask you for all angles, you're going to see they ask for that in this next problem. If I ask for all angles, you could be like listing them for hours because you could add 360 over and over and over. All of those would still be coterminal. So we need to write that as an equation if we're representing all angles. So we would write this as 60 degrees plus 360 n, where n is an integer. That is an equation to represent any coterminal angle for 60 degrees.
That's it. Every.
I know, I need it.
Yeah, okay.
So like that means if it's 4,
I have it written down.
where if this is like 4, that means 4 times 360, think of that as 4 circles. If I start at 60 degrees and I go 4 perfect circles, I'll end up in the same spot, right?
Okay.
And so it doesn't matter how many times I go 360, any multiple of 360 works. So that's what that n means.
Oh, okay,
It could
bad.
be anything like that. Okay, so now radian time. Radians, same drill. Theta plus, but in 360 is in degrees. So anyone in here remember from earlier this week when we learned the conversion, 360 degrees was equal to, look, lots of people, Isaiah?
2 pi.
2 pi, and we're going to say 2 pi n again, where n is any integer, and that just means, again, 1 circle, 2 circles, 3 circles, any multiple of 2 pi. Sure, however many you want. Okay, so then the example could be, we would need a angle in radians, so recap, let's use 60, but I want that in radians, so we're doing a lot of good review here. The conversion for multiplying, who's got it? We should feel comfortable with this like feet and inches now. This should be like second nature. How do we go from radians to degrees? How many radians to how many degrees, Diamond?
You have to do the from radians to degrees.
Degrees to radians.
Oh, you have to do the pi over.
Pi over 180. And then simplify, and you'll end up with pi over 3. 6 divided by 18, yeah, 1/3. So we end up with pi over 3 plus 2 pi n. That's our starting angle, plus any multiple of a full circle will get us to the same terminal side. Okay? Okay. So we can, at this point, find the equation to represent all of the angles. You can also find a specific positive or negative, like as an example, and then we should be able to also sketch or draw them. So that's what you're going to be asked to do in these problems right here. We're going to start with degrees. We're going to do 1 degree problem together. You're going to practice 1 degree problem with your neighbor. Then we're going to do 1 radian together. Then you're going to practice the radian with your neighbor. So let's look at the degrees. We got 45 degrees. Same thing as this equation. Cristobal, can you help me out? I need to identify all angles that are coterminal, which means I need an equation for the coterminal angles. What could you do for this?
One of the 45 degrees plus 360 and
Perfect.
easy.
Okay? So that is part 1. Check. We found all coterminal angles. We wrote an equation for them. Okay? Next up, it says find and draw 1 positive and 1 negative. So now, similar to what we did with 60 degrees, I want to find a positive angle and a negative. Adrian, you got one or you got a question?
I got one.
Got one? What did you do?
Oh, you know, you put the 45 first?
Oh, you found it first. Whee! Okay, he drew it. And it's halfway between 0 and 90, so he said it's right here.
And then for the negative one, you start at start at the initial, and then go all the way to the left side, to the angle. Yeah, that's the positive.
Like that? Cool. And do you know how many degrees that would be equal to?
300, negative 300, 15.
Cool, so you do 45 minus 360 would be negative 315 degrees. And then he drew the picture like that, where you would start at the initial and go back. And it makes sense because, did I go a full circle? So notice this is less than 360, so like the size of it makes sense with our picture. Yep. Instead of going forward 45, you go down 45. Okay, and then next up, let's do the positive one because that's a negative. Check. Check, we got a negative. What could we do to find a positive coterminal angle, Joanna? Yeah, we gotta go counterclockwise. So we would start here and we'd have to go all the way around and back. Because there's no other way to hit that terminal side unless we went straight to it, but that's 45. So we would have to go past it and back to it. And so that angle is 45 plus an extra 360. Aggie?
Wait, so you know how we did the equation? Does that only work for the, yeah, the positive?
Because think like if n was a negative 1, that's this equation. Negative 1 times 360 is negative 360 to be minus. If I multiply 360 times negative 2, I'd be taking away like 2 circles. Cool? So that's why, yeah, you could write this as 60 minus 360n and 360 plus 360n, but we don't need to split it up because n could be positive or negative and it covers all that. Yeah? Okay, so then 45 plus 360, what is the degrees of this pink one? It would be, oh, there it came from. Found it. That's what I was writing earlier. I was just trying to remember answers from earlier. 405. All the numbers are in my head. Okay, so I have a positive, I have a negative, I have my equation, I have my picture. Okay, I want you all to try that. Not the one to the right, the one right below that's in degrees. We're going to come back and do radians, okay? Go ahead and do negative 30 degrees. See what you come up with. The last time I just said do that one and then I walked around like half people are like, what's that called?
I don't know what I'm doing.
Trying. Okay, I think I was thinking Stand friends. Stand friends. Okay, so negative 30. What's your equation? Plus 360. Just like this. What? You keep writing 35, man.
Yeah.
You gotta do it yourself. Okay.
You got this.
Oh,
Use the
no.
formula.
Actually, all you need is
So it'd be negative 30, right?
negative 30 plus 360 and then just plug in random number.
So see, so for the negative, I'll put negative 1.
Sure. Okay, negative 1, negative 10.
Good. So instead of going 30 degrees here, negative, remember means going down, and our other is 30 degrees here. So your initial side stays where it is. It doesn't like flop over here or something. Your initial, yeah, I've seen that a lot. Because we think x's are like negative over there. But your initial side stays where it is. Instead of opening positive 30, it goes negative 30. So 30 degrees down. You go for it. Good. Good.
Yeah, first I want to
Because when you go like negative, right? You use negative 1, right? Yeah, it's flips.
360 times negative 1 equals negative 360. Negative 360 plus negative 30 is negative 30.
Okay.
Everything on there. Everything. Yes, good.
Positive, right?
You just do positive.
Positive.
So do negative 30.
Because that's positive.
Same thing as negative minus 360.
So we're trying to find negative, use the negative 1.
Yeah, and you can write it like that, yeah.
I get
But I would just start with it, what you have, and then take away 360 or
I don't know about this term.
Few more seconds. I'll catch up up here. Write it. Okay, eyes up here. 5, 4, 3, 2, 1. So we get on to radians, we play our game. So this is your equation. I assume, again, there's actually multiple positive or negatives you could have done if you happen to do like 2 circles, right? They just asked for a positive or a negative. But I assume, and I saw when I walked around, most people chose to do 1 circle forward or 1 circle backwards, which means you end up with a positive 330 and a negative 390, okay? In terms of the picture, when drawing negative 30 degrees, positive 30 is going from your initial side going up 30 or something like that. So a negative 30, you don't flop to like the other side, you just go down 30 like this. So a negative 30 would be closer to 0 than the 90, because 30 is closer to 0 than the 90, but somewhere roughly around there, okay? And then that means our pictures would go positive, less than a full circle to get around. 330 is less than a full circle. Or negative, you'd have to go all the way around and back down. That would be your negative 390, okay? All right, let's talk about radians. A lot of y'all could probably get started on this. So the equation works the same way. Raise your hand if you can knock the equation out for us for this, going back to part B of the one above. Let's see who I heard from. Isaac?
It's negative pi over 3 plus 2 pi. And
Okay, that would be our equation, because remember the only thing we change with radians is we're adding, instead of 360, 2 pi, because we want our units to be the same, okay? So here's our equation. Now we've got to actually add the 2 pi or subtract the 2 pi. Okay, and that's where we might have some questions, because not as easy as just adding numbers like this, because we are dealing with fractions, but you're going to be okay. So we're going to say negative pi over 3 plus 2 pi. If I take negative pi over 3 and I add a circle, I need to, in order to add fractions, I need a common what? Denominator. So let's think about 2 pi. If I want to write 2 pi with a denominator of thirds, I want to like basically multiply times 3 on the bottom, which means I need to multiply times 3 on the top. What's 2 times 3? Do you agree that 6 pi over 3 is the same thing as 2 pi? This simplifies to 2 pi, right? Happy? So I'm going to rewrite this as negative pi over 3 plus 6 pi over 3. Do we all see where the 6 pi over 3 came from? Okay. Negative 1 plus 6 would be what? 5 pi over 3. So here is a positive angle in radians. When we add 2 pi, we just changed it to 6 pi over 3 to have a common denominator. Now, a couple people today have asked me, like, can I change this to degrees and then add 360 and take away 360 because I just like degrees? That's fine, but at the very end, I don't want you to leave your answer in degrees. That means then, both of these answers, you also need to convert back to radians. So you end up converting like 3 times. So it's kind of up to y'all to see if you feel like that's worth your time. I know right now we might be uncomfortable with radians, but they're going to become more second nature. They're just new to us right now. And so I'm going to model sticking with radians, but if you want to change to degrees, you should get the same thing, okay? Okay, now let's go negative. So if I say negative pi over 3 instead of plus, if I subtract, because I could add or subtract a full circle, What's our full circle? But how can we write it with thirds? 6 pi over 3, I'm going to use the same, that's equal to 2 pi, 6 pi over 3. If I have negative 1 minus 6, I end up at negative 7 pi over 3. Hello. Oh, negative 7 pi over 3. Okay. So the difficult thing about the radians, though, in addition to just having to find a common denominator, is we're a little bit probably less familiar with how to draw radians, because 60 degrees, you're always like, oh, it's less than 90, I know where 90 degree is. When we talk about pi over 3, it's like, I don't know where that is. So, you could, again, convert 2 degrees. We actually already did pi over 3. What was pi over 3 equal to? From earlier? 60. So this is like, we could be thinking in our head that this is equal to negative 60. So we could picture it being not 60 up, but 60 down, somewhere like this. Or, if you want to start thinking in terms of the unit circle about how to label radians without always converting them, think about it as a fraction. We're taking pi and we're splitting it in 3, right? Where is pi? Where's pi? Well, we talked about that earlier this week. Where's pi? Pi is equal to what? 180. Pi's over here, right? So 180 degrees, if 360 is 2 pi, 180 is 1 pi, right? So pi is over here. So this means that negative pi would be like going all the way to this flat line, like back 180 degrees or back to pi. Okay? We don't want to go back pi, we want to go pi thirds, or like a third of pi. So if you notice, if I split this into 1, 2, 3 pieces of pi, split your pi in 3, this is 1/3 of the pi.
That's why it's 7 pi when you go.
If I wanted like negative 2 pi over 3, we could go to this second dotted line, like 2/3 of the pi.
I see.
Okay.
Okay.
This little guy?
Yeah.
No, but I feel like it makes sense in my brain, might not in yours, but you don't have to. Okay, so negative pi over 3 would be right here. You can use degrees if you'd like, you can use your thirds if you like, okay? Okay, and then swirly time, let's see, if we go 5 pi over 3 positive, that would be like this, which makes sense because it is less than a full circle. Is 5 pi over 3 less than a full circle? A full circle is 6 pi over 3, so yes, cool. Okay, now let's do the other one. Negative 7 pi over 3. We'd have to go around and back. More than a full circle. That makes sense because 7 pi over 3 is more than 6 pi over 3, a full circle. Okay? Alright, try that out. Then we're going to do game time. Go ahead and try the next radian one right below. See what you and your neighbors can come up with, then we'll check it. If you're already feeling good and done, I can come and check. Good, try this again. It's a little harder. Call me over when you're done and I'll check it and send you on to the multiple choice below. I'm just looking at your swirl for the last one.
The swirls aren't bright.
Just the negative one. I mean, it's coterminal, but it's not negative 5 pi over 4. It's like a bigger negative. So just this piece
Yeah.
would be negative 5 pi over 4, like a full circle. Try that in multiple choice. Let me show you. Wonderful. Okay, for your picture, 3 pi over 4, positive or negative? So unlike this one where we went down, this one we're going to be headed up, and we're going to go 3/4 of pi, like if I were to split it into fourths. Or, Oh, that would be if degrees were out of 100. So actually that doesn't work. So it would be 3, like, do you agree 45 degrees is a fourth?
Yeah.
Right?
Yeah.
Positives. 90 plus 45, 180. This is 1/4, so 3/4 would be to here. And if you convert this, if you multiply times 180 over pi, you'll get
Oh.
Actual pi.
okay, with
Hey,
these,
you're talking about the
oh, you were doing this one. So now you're doing this one up here.
Sorry,
I hate when
I don't need pi.
Let me see.
one more day.
Oh my god.
But that's a full pi. Like, actually, technically, pi is just half. That's 2 pi.
That's 2 pi.
It looks like a whole pie, but it's 2 pies.
That means we try pi, you get half of that.
Lovely. The answers look good. Okay, try that multiple choice problem if you're waiting on us.
No. I said no. No.
Yeah, you have 3 pi here. Multiply by 4.
We're left now.
I mean,
2 weeks.
I think later you'll have 6, and then you'll have 12 pi or 6, and then you'll be right. So just 8. But your process is correct. You just do your fraction. Thank you, Leo, for clarifying. Oh, no. It's okay. It's back. Okay.
Yes, you are.
Okay. Take a look. Check your answer as I write it up here. Okay. Well, you want the actual number, and like, so we're saying n is 1, right? Like, if n is 1, then we're trying to now actually add and get like a number. So we don't want an n in it anymore. But this is perfect. Everything's good. It's like, yeah, these ones. I see how here we just don't work. Okay. Eyes up here. What's the top? Take a look. 3 pi over 4 plus 2 pi n. That's your equation. Your positive angle, 11 pi over 4. Your negative 5 pi over 4. And I showed you what my fraction should be for 2 pi if you needed help finding that. Other than that, the only challenge might be drawing the terminal side of your angle. I'm not going to draw all the swirls, but if this is my initial side and I'm going to 3 pi over 4, you can either think about splitting the pi into fourths, and you want 3 of them, or you can change it to degrees, and you get 135 degrees, and that is right here. And so that's where our angle should be, and then we go forward and back with the rest of our picture. Okay? I'm going to move us along. Okay. I would encourage you, for time right now, I'm actually going to not have us solve this problem, but I think it's a rigorous problem because it involves degrees and radians, so challenge, and finding coterminal. So you're having to do conversions and adding and subtracting 360s to find one that works. What we're going to do is spend the last 10 minutes trying to play a competition game at your tables. So I'm going to show you. Listen up. Listen up. I'm going to show you a set of degrees or radians or a picture. Y'all, Isaiah and Brian, you just joined another table, okay? And what you're going to do is you're going to lay out your cards, and you have to find anything that matches the one I show you. So it could be in radians, it could be a conversion, or it could be a rotation of some sort of coterminal angle, or it could be a picture, anything that works. There could be 1 match, there could be 2 matches, there could be 3 matches. I'm not going to tell you how many, You have to see how many. Anyone that you matched correctly, you get a point.
Okay.
Anyone that you matched incorrectly, you put something in that shouldn't be there, you get minus a point. Anything you just missed, you didn't put in, you get 0 points for it, okay? Alright, so here we go. First one, try to find anything that matches 330 degrees. And the back of your notes is blank, so you can use that to like add or subtract or do things that you might need to.
We want a negative 30 degrees. Give me a negative 30. Give me something else that we
So
separate.
we got 330s.
Give me something else that we separate
Radians where you
negative 30.
could take away or add
Give me something for here.
360.
Give me something else that we separate negative 30. That should be all.
You got 330 plus, if you have 330 plus, in order for it to be the same, you have to add 360 or take away 360, right? So try 330 plus 360, 330 minus 360 and see what it's Negative 30, do y'all see a negative 30 around town? Okay, there's a picture of negative 30. You get a negative 30 like that, so both of those match. Okay, let's see if we can figure out what that is in radians. See if there's any radians. Convert by doing times what?
I did all the work you guys did.
However many. You don't want to convert this big one. You can now convert one. About 10 more seconds. You're good? Shouldn't learn anymore? Sure you don't have any that you shouldn't have? Do we all understand why they work? Do we understand why? No? Sending me mixed messages here. 5, 4, 3, 2, and 1. Okay, everyone choose a scorekeeper at your table. Someone that shows integrity, not a cheater. They're going to award your points as you get them or take them away as you have an extra one that you should not. Okay? Final decision has been made though, so put to the side. Put to the side anything that you are committing to. You cannot add or change at this point. Okay. First one that you should have is B, negative 30 degrees. If you got that, give yourself a point. Okay. Next up, you should also have L, because that's the picture of negative 30 degrees. If you have that, give yourself a point. The last one is if you change it to, if you convert to radians with pi over 180, it is negative pi over 6, and so that would be E. So that's your last point, or if you added in any extras, take away a point. Okay? Alright. Anyone have 3 points? Okay, a few tables. Close. Okay. Next up, matches for pi over 2. Matches for pi over 2. Find anything that matches pi over 2.
This thing.
That's all.
Yes, this thing too. Wait,
I'm not really understanding.
there might be more. There might be more.
Jason, you helping?
No, this thing too.
Is pi over 2 equal 1 degrees?
There could be a lot of answers.
Oh, yeah, we're done. Could be. Not done.
Oh, this thing is also answered. No, this is nothing.
What are we doing, bro? We're gonna do that.
Wait, what's 360 plus
5,
90?
4, 3, finalize your submissions. 2, and 1. Okay, at this point, you cannot add in any more cards or take away any of the ones that you already have, so you are committed completely to those. So let's check really quickly. First one I found was I, because that's 90 degrees. So if you multiply this times 180 over pi. If you look at the picture, that would be M was 90 degrees like this. So that's a second one that you could have had. Okay, the other one that I noticed was A is just not simplified. If you simplify 2 pi over 4, that's pi over 2, that's equivalent. Are there any others?
Yeah.
What other one? K is negative 270. Because if you add 360, what do you get? 90 degrees. And that's it, right? Okay, so if you had those, then 4 points. If you added in, take away a point. If you missed one, then you just don't get it, right? Okay. Point update. Who has 7 is the max, right? Okay, we got 2 tables still in the running towards becoming the radiant degree masters of the world. Okay, next up, here we go. The 3. Rapid speed round to try to get tiebreaker between these 2 tables. A little bit.
Finish.
It's not a race.
Wait, just.
No, I don't know.
No, it's negative. How is that gonna equal 6? Okay, well that
Yeah, we're
equals 6.
done.
Wait,
It's a speed round.
So do you find add or subtract? 360. 5, 4, 3, 2, 1. Hands off your cards. Okay. For this one, you could have had that pi over 3 is equal to 60 degrees, which was what? D. D?
Yeah.
Okay. That's one that you could have had. Then, if you look at N, that is the picture of it. So that's another one. And then last, you could have had J420 is if you take 60 and add 360, so it's coterminal. Okay, so that was 3 points possible there. Are we still in the running?
Yeah.
Are you guys still in the running, Diamond's table?
Yeah.
Okay, everyone else still battling it out? Anyone just missing 1 for the whole game? Okay. All right, 2 minutes. You've got 30 seconds. Let's try to see if we can tie break 30 seconds to see who can match the most.
Where's the last?
10, 9, 8, 7, as many as you can. 6, 5, 4, 3, 2, 1. Hands off. I believe, if I have my key correct, just C and A. Just 2. C and F. Did you all get both? Or 1? Just 1? How many did you all get? 1? Come on! Tie game. And I got 2. 3-way tie. Alright, go ahead and put your cards in the paper clip. Please, I can use these again.
All